Hello everyone, myself Vishalini, second CECB from Kongnadu College of Engineering and Technology. Today's our topic is interprocess communication. First, let's get into the topic. What is interprocess communication? Interprocess communication enables process to communicate and share data effectively. It ensures synchronization, parallel execution, and resource sharing in multi-process system. Why it is important? Essential in multi-user, multitasking operating system. Used in real-time application and cloud computing and distributed system. Real-world examples. Web browsers, different process handle UI, page rendering, and network independently. Cloud databases. Multiple servers update records while maintaining consistency. Key takeaway: IPC enables efficient multitasking, better performance, and system scalability. Types of IPC. There are two types. First one is message passing, second one is shared memory. Methods of IPC. There are two methods. First one is direct communication, second one is indirect communication. There are 6 IPC mechanisms. First one: pipes, message queues, semaphores, shared memory, sockets, and signals. Types of IPC. First one is message passing. Process send and receive message to communicate. Used in distributed system and client server models. Example: a web app frontend sends an HTTP request to a backend API. Second one is shared memory. Multiple process access a common memory space. Fastest IPC method but require proper synchronization. Example: multiple threads of a database updating cache memory. Are two methods of IPC. First one is direct communication. Process communicate directly without intermediates. Example: a parent and child process exchanging data in a Linux shell. Indirect communication. Message are sent through a message queue or mailbox. Example: cloud-based microservices using Kafka or RabbitMQ. Key takeaway: message passing is safe but slower, while shared memory is faster but needs synchronization. There are 6 IPC mechanisms. First one is pipes, a unidirectional communication channel between process. There are two types of pipes. First one is anonymous pipes, second one is named pipes. Anonymous pipe is used for related process, example parent child. Named pipe is used for unrelated process, example inter-application communication. Example: Linux command is grep file, passes output between commands. Second one is message queues. Message queues is a mechanism that allows process to send and receive message asynchronously. It holds message until the receiver is ready to process them. Example: cloud servers like AWS queues process requests independently. Third one is semaphore, a mechanism for synchronization and preventing race condition. Example: preventing two ATM mechanisms from responding for same cache simultaneously. Shared memory. Multiple processes directly read or write in a common memory space. A game engine used to share memory for physics calculation. It is an example of shared memory. Fifth one is sockets. Communication mechanism for network process. Example: web application where clients communication with the servers over TCP or IP. Sixth one is signal. Use it to send event notification to a process. Example: pressing Ctrl+C in Linux sends a signal to terminate a process. Key takeaway: different IPC mechanisms serve different needs, balancing speed, security, and complexity. IPC synchronization mechanisms. First, what is the definition of this mechanism? Synchronization is needed when multiple processes are accessing shared resources like data or memory. There are two. First one is mutex, mutual exclusion locks. Ensure only one process access a resource at a time. Semaphores controls how many processes can access a resource simultaneously. Deadlocks in IPC. A deadlock happens when two or more processes are stuck waiting for each other to release resource and they never proceed. Example: two trains in an intersection point, each waiting for other to move. prevention strategies, resource allocation, ordering, avoiding circular weight. Race condition in IPC. Race condition happens when two or more processes try to change shared data at a same time leading to errors. Example, multiple users withdraw money from the same bank account simultaneously. Solution, using locks and synchronization techniques. Key takeaway, proper synchronization prevents deadlock and race condition. IPC performance and optimization. Time must take for message to travel from one process to another. We want to reduce this time to make communication faster. It is latency, extra work that the system does to handle IPC. We try to reduce overhead by using more efficient methods like shared memory instead of sending message. This is overhead. IPC distributed system process communication over a network instead of a shared memory space. Common IPC methods, first one is remote procedure calls RPC, second one is message queues. RPC is one process calls a function another process over a network. Message queues used in cloud-based application for scalability and reliability. Example, microservice architecture in Netflix. Real-time system. Process must communicate within strict time limits. Example, self-driving cars, sensors and control system communication in real time. Medical devices. Life support system require real-time IPC for monitoring patients. Multi-threading and IPC. A thread is a smaller unit of a process. Multiple threads within a process need to communicate with each other. Example, a web browser where one thread leads the page and another handles user input. Thread communicate via shared memory but need synchronization to avoid issues. Secure IPC. IPC can expose sensitive data, so it's important to keep it resource. Encryption. Scrambling messages so no one can read them unless they have the key. Access control, ensuring that only authorized process can send or receive message. IPC in cloud computing. In the cloud computing, multiple services, app or database running on different mechanisms need to communicate. Message queues like AWS, SQS or PubSub system are used for reliable communication between services. Example, a weather service sending data update to a mobile app. Key takeaway, IPs is crucial for distributed, real-time and cloud-based communication. IPs in real-time system. Process must communicate within strict time limits. Example, self-driving cars. Sensors and control system communicate in real time. Medical device. Life support system require real-time IPC for monitoring patients. Challenges and solution IPC. First, let me know challenges. Process waiting indefinitely. Overhead system resource consumed by message queues and synchronization. Security risk. Unauthorized access to IPC channel. Solutions. Use of efficient synchronization, primitives, careful resource management, and timeouts avoid deadlocks. Advantages of IPC. Data sharing allows process to exchange data. Modularity breaks tasks into smaller manageable process. Efficiency. Share system resource effectively. Concurrency. Process can run simultaneously. Synchronization prevents error like race condition. Disadvantages of IPC. Complexity. Hard to manage multiple processes. Overhead. Extra time and resource needed for communication. Deadlocks. Process can get stuck waiting for each other. Security risk. Data can be exposed if not secured. Latency. Communication can be slow, especially across machines. Conclusion. Interprocess communication essential for enabling efficient communication and synchronization between processes. Different IPC mechanisms like pipes, message queues, shared memory, sockets, semaphore and signals are used based on performance, security and system requirements. Synchronization techniques like mutex and semaphore help prevent deadlocks and race condition in shared resource environment. IPC plays a crucial role in distributed computing, real-time system, cloud computing, and modern operating system, ensuring smooth multiprocess operation. While IPC improves performance and resource sharing, it also introduces challenges like security, risk latency, and complexity which must be managed efficiently. Understanding IPC methods and choosing the right mechanism helps in designing secure, scalable, and high-performance system. Final thought. Efficient IPC is the backbone of modern computing, enabling seamless interaction between process device and distributed system. Thank you.